So we're looking at 6.5, which is rhombi, plural for rhombus, and squares. And we're going to recognize properties. Recognize properties for both. And then we're going to do some determinations about what things are. Rectangles, rhombi, which is plural for rhombus, and squares. So our three vocabulary words are rectangle, which we've had before. I just want to put them all together. Is a quadrilateral with four right angles. A rhombus is a quadrilateral with four congruent sides. A square has both. Has both. So a square is a special type of rectangle, and it's a special type of rhombus. So it's both. We can see that in the Venn diagram where we have the left oval that has all the rectangles in the world in it. The right oval has all the rhombi in the world in it. The left, with all the rectangles, has the four right angles, all the quadrilaterals with four right angles. The right has all the ones with four congruent sides, and they can look something like that. They don't have to, look like a square because they're not. And then you have the convergence of the two things, and that's when it's both. It's a rectangle and a rhombus. It's got four right angles and four congruent sides. We call those squares. So we have some conditions for rhombi and squares. The first one says, if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. So if the diagonals are perpendicular, remember, if it's a parallelogram, the diagonals bisect each other. That's not what we're talking about right now. I'm just reminding us that that's true. If it's a rectangle, they are congruent. But that's not what we're talking about here either. Just reminding you. But if the diagonals are perpendicular, then it's a rhombus. That's one way to know. 6.18 says, if one diagonal of a parallelogram bisects a pair of opposite sides, then the parallelogram is a rhombus. Now, when they say bisect, it means like that is congruent to that, and so on. And that's noted here. Well, there's the actual one, but those are all noted there. So the diagonal bisects the opposite angles, then it's a rhombus. So both of these have to do with rhombus, and so does this one. And it says, 6.19 here, it says, if one pair of consecutive sides of a parallelogram are congruent, then it's a rhombus. So if one pair of consecutive sides are congruent, notice these are not opposite sides, they're consecutive sides. So if consecutive sides are congruent, then it's a rhombus. Because we already know from parallelogram that opposite sides are congruent. So that makes all four of them congruent. And by definition, that's a rhombus. The last thing we have down here is if a quadrilateral is both a rectangle and a rhombus, then it's a square. We've said that already. So it says use the properties of rhombus up here. The diagonals of a rhombus, W, X, Y, Z, intersect at V. Intersect at V. That's kind of obvious, but okay, we stated it. WZX, which is this angle here, is 39.5. Find the measure of ZYX. This angle. Well, we'll have to do some little figuring here. First of all, it's a rhombus. So all the things you know about a rhombus apply here. And I believe That said, this is 39.5 also, because the diagonal bisects the angle. That makes the whole thing, just so we can see it, it makes the whole thing 89. So, of course, this one's 89 also. But the question is, what is this one? Well, since these two angles are consecutive angles in a parallelogram, rhombus, parallelogram, they have to be complementary or supplementary. So they have to add up to 180. So if they have to add up to 180, then this is my brain's not working. 91, I believe. No, 101. My math's bad. Oh, here's where my math's bad. That's 79. That makes that 101. That makes that right. There's the 79 and the 101. I wonder if there's another way we could have done that. Maybe not. My mind was working on another thing. We'll leave it at that and we'll move on. The diagonals of a rhombus, W, X, Y, Z, intersect at V. That sounds like something we've seen before. WX is 8x minus 5. WZ is 6x plus 3. They do tell us it's a rhombus. And he asks us to find x. Well, hopefully we know that these two sides are congruent. Why? Definition of a rhombus. A rhombus is a parallelogram with 4 congruent sides. So that means the 8x minus 5 has to be equal to the 6x plus 3. So that's 2x equal 8, x equal 4. What they asked me to find? The x. Effectively, I'm done. Now, I hope I have made it clear to you that if x is 4, that we should check. So if x is 4, you put that 4 in there, you get 27. X is 4, you put that 4 in there, you get 27. That's good math. Checking is good math. X is 4. That's what they asked us for, not the 27. Just make sure you answer the question. So they tell us that ABCD is a rhombus. They tell us that the measure of angle CDB, which is this one, is 126. Then they ask us for ABC, which is this whole thing, this angle. Well, if we follow the logic of the previous problem, then this is 126. Wait a minute, did I do that right? C, D. Oh, I'm not even reading correctly. Find CDB if this is 126. Okay, I guess you thought I'd lost my mind. No words. So, since opposite angles of a parallelogram, because a rhombus is a parallelogram, since opposite angles are congruent, then this whole thing right here is 126. And if that's true, then how much is half of it? Because that's what the diagonal does. is bisect. So half of 126 is 63. Answer is B. So it tells us that ABCD is a rhombus. It tells us that BC is 4x minus 5. And that CD is 2x plus 7. Since those two sides are congruent, it shouldn't be hard to set up an equation and solve. It'd be a good time to pause the video and just practice that. But we have the 4x minus 5 equal 2x plus 7. So 2x equal 12. X is 6. Answer is D. We could plug those back in and prove that to be true. Answer is D. So we saw this before, and this is where we're going to get into this, like, how do we know? How do we know? But we've seen all these before. Like we saw all these pieces, every one of them. If the diagonals are perpendicular, it's a rhombus. I'm looking at this one. If the diagonals bisect the opposite angles, then it's a rhombus. If one pair of consecutive sides are congruent, then it's a rhombus. And then if it's a rectangle and a rhombus, then it's a square. So here we have a situation. Hector is measuring the boundary of a new garden. He wants the garden to be a square. He has set up the corner stakes 6 feet apart. What does Hector need to know to make sure that the garden is square? Well, what Hector has is not enough to make sure that it is square. Hector would need to know that's a right angle, for one thing, or that would be one thing. If he knew that was a right angle, then you could proceed from there. But Hector doesn't know that just because these are both 6. It could be a rhombus and not a square. So you'd have to know that. So you'd also know it was a rectangle. And that's what this says here. This says, it could be just a rhombus. So Hector needs to know if the diagonals are congruent. Okay? So I said he needs to know that's a right angle. They're saying he needs to know that the diagonals are congruent. Because the diagonals are congruent, it's a rectangle, and that means that angle is a right angle. Sachin has a shape he knows to be a parallelogram, and all 4 sides are congruent. So it's a parallelogram, we know that, with 4 congruent sides. We call that a rhombus. A rhombus. Which information does he need to know to determine whether it's also a square? Diagonals bisect. That happens in all rhombi. The diagonals will bisect each other. That happens in all parallelograms. The diagonals are perpendicular. That's your answer. The diagonals are congruent. Maybe that's the answer. Okay, so I started to put this one, but I got myself a note right here. It says that's a rhombus, not a rectangle. In fact, in a rectangle, let me draw an exaggerated rectangle. I'm pretty sure those are not perpendicular, but a rhombus they are. And a square they are because it's special. So determine whether parallelogram ABCD is a rhombus, a rectangle, or a square. And they've given us these vertices. It says list all that apply. So I've just made a note here that we know the rhombus has all sides congruent. Rectangle has, and both of these, of course, are parallelograms. The rectangle has all angles are congruent, so they're all 90. They're all right. And then the square has both the rhombus qualities and the rectangle qualities. So we're going to see what we've got going on here. So I've also noted that for a rhombus, the diagonals are perpendicular. For a rectangle, the diagonals are congruent. For a square, they're both. So those are the pieces or parts that we have to work with. So we've got the picture here. I've blown it up. So they want to know, and let's make a little note over here somewhere. Is it a rhombus, a rectangle, square? And we know it's a parallelogram. Let me go back. We know it's a parallelogram because they told us it was a parallelogram. So we got that. That's nailed down. So the question is, what else do we know? We could prove that it's a rectangle by looking at the slopes. Because if this is going to be 90, what would have to be the case of this line and this line? They'd be perpendicular. And what we know about the slopes of perpendiculars? They're opposite reciprocals. So let me talk about the slope of this here. It's rise 1, run 1, 2, 3, 4. Rise 1, run 4. So I'm just going to make a note of that. Slope is 1/4. What's the slope of this line? It's rise 1, 2, 3, 4, run 1. Oh, I should say that was a negative 1/4. So this one is rise 4, run 1. Are those opposite reciprocals? The answer is yes. So that is a 90. If it's a parallelogram, opposite sides are congruent and consecutive, or not opposite sides, opposite angles are congruent, consecutive angles are supplementary. So remember, we had that little rule that said if you got one, they're all right. If you got one right, they're all right. So I just proved that it's a rectangle. I just proved it's a rectangle. So let me erase that. It's a rectangle. Okay. Now, let's talk about, is it a rhombus? Because if I can prove that it's a rectangle and a rhombus, then I can say it's a square. So the next question is it a rhombus? Well, a rhombus has all sides congruent. They have to all be congruent. A rhombus also has diagonals that are perpendicular. So I think I'm going to try that one. Diagonals are perpendicular. That means they make a 90. Now I can't tell by looking, so I got to tell by working. So they have to have certain slopes, right? So I'm just going to dot this one. I'm going to start here, and I want to dot 1, 2, 3. So rise 3. Run 1, 2, 3, 4, 5. So the slope of this one is rise 3, run 5. Okay, I'm going to erase that to get it out of my way. Because now I want to find the slope of this other one from here to here. So I'll rise 1, 2, 3, 4, 5. Run 1, 2, 3 in the negative direction. So the slope of this one is negative 5/3. Are those two perpendicular? Yes. So if the diagonals are perpendicular, then it's a rhombus. And since it's both a rhombus and a rectangle, it is a square. Now they went through this. You can sort of see how these work. but they ultimately did say the same thing that we just said. They're all three. Here's another one, somewhat similar. We would need to work through and play with. I'll leave you to it. If you want to pause the video, you can go work on it for practice, but it is also all three.